So we're now going to have to make an input for these values. From the shader inputs we get a position, color, texture coordinates. Let's keep it simple. We're going with the fact 3 here as well. We can optimize this later on as well. Let's call it lighting direction. Lighting direction, that's what we get from the buffers. And then we just pass that along. So this is simply passing this along. Now it doesn't work because we actually don't receive the input, so this value probably gets stopped to 0. Let's open up the render engine, OpenGL, here we go. And let's open up the render vertex definition in the right screen. So okay, this is like the data we're sending over to the GPU. Here on the left side we are actually sending the commands to say like, okay, this is what you're going to get. You're going to get these vertex attributes. And here you have the definition of those. So we have 4 signed shorts with the position. We've got 4 bytes for the colors. We've got 4 bytes in total for texture coordinates. Then we send over the normals. We have shadow factor, artificial light. This is the X, Y, Z, W lighting components. We're going to add 4 more bytes here, and let's call them lighting direction X, lighting direction Y, lighting direction Z, and then we have another unused. We're not going to pass that to the vertex shader. So the vertex size changes. We now have a 4 times 1, 4 times 1, 4 times 1. So there's another term here, 4 times 1, that we're going to have to supply. We can still divide it by 4, we can still divide it by 2, and of course we can still divide it by 1, that's always possible. Some offsets have changed, so we might have to update the render vertex CPP material. So the material is now on 1 index higher. The material map is also 1 index higher, and the normal map is also 1 index higher. We can make a setter already, render set lighting direction, and then we want a const, we use int ATs here. So we're going to, this allows like external code to set up the direction of the lighting. I like to keep the code consistent, so we can copy the definition. Set lighting direction const X, Y, Z, that's cool. Store lighting direction. And it's not at 16 then. If the normal starts at 16, this is 16 plus 0. Then this is 17, 18, 19. This is 20. 21, 22, 23, 24. So we start at 24 here. It's a bit like, yeah, you're working with raw data here. Okay, so we can now set the lighting direction on render vertices. We need to tell a few parts that we're sending another attribute array. So that's now 9 things. 1, 2, 3, 4. Yeah, it's 9 things, of course. Let's open up the render vertex for reference. So 9 things in total. Position is 0. So 1 thing, 2 things, 3 things, 4 things, 5 things, 6 things, 7, 8, 9. Okay, so this is 9 groups of properties that we're sending over. So we enable 9 groups of properties in the render engine. The attributes themselves, position hasn't changed, the color isn't changed, the texture coordinates are the same, the normals are the same. Lighting information, that's this one if I'm not mistaken, is the same. And then we get another set. ADGL exec, that's a wrapper that calls an OpenGL call and does error checking on it. So if there's any OpenGL error, it will print it to the screen, program will just halt, and you will know what's wrong. We have a new attribute at position 5, it says, and let's see, 0, it's actually 6, so 0, 1, 2, 3, 4, 5, it's actually correct. It consists of 3 elements. We're sending over bytes, because each of these components is a signed byte, so it's a byte. Do we want to normalize them? It's probably free. Let's normalize them. They're render vertex size apart, and they start at, it's a void pointer. Yeah, this is kind of like OpenGL syntax, and we start at what the previous one started at. It's 24, and then this one is attribute number 6, starting at 28. Then this is 7 starting at 32, and then this is 8 starting at 36. Let's see if we run what it looks like. I'm not sure if things are actually okay, because take a look at the shading of the builder. Take a look at the shading. It's actually, something is Something is amiss here. What we now need to do is to make sure that, I think it's the render state manager, OpenGL, that this guy knows about all of our properties. So let's see. Yeah, here we go. We have the attributes here. So buffer position, sound familiar? They sound familiar. So we're going to insert another one here at position 5, lighting direction, because it was using the old indices. So let's call this one 8. There we go. And we add, and we make sure, okay, so we actually check these as well. So let's make sure that OpenGL and we are on the same page. Lighting direction. So we also pass in some uniforms and stuff, but that's not interesting. So we added our attributes in the communication with the Vertex shader as well. And now things should look good again. Yeah, so we definitely have our metallic buttons again. We have our builder looking good.
Underway, so let's go.
Okay, we don't look like a sea of stuff here. Let's go into the render buffer here. This actually is the class where you pass in model vertices. So you can say like, I want to add a quad consisting of model vertices. That's kind of like the glue between the engine and the rendering pipeline. And this one converts those model vertices to render vertices and kind of like tries to reuse them if possible. So here we are going to say render vertex. Here we're going to hard code it. Set lighting direction 0, 0, and then int 8 max. So now we're going to set it up. It should look the same, and then we can start testing from the code. So instead of this being in the shader, it's now actually in the engine, which is where we want it. So okay, it looks similar, but I think it's got way more power to it. So I think previously it was set to 0, 0, 0. So let's go with, let's maybe just denormalize this thing. Int 8 max, int 8 max, int 8. The idea being that the light now comes in from the northeast and the top at
underway, so let's go.
Hey, this is actually, it's working. See, the light is actually coming in. It's actually coming in from the northeast, from the left and to the back of us. See it? It's actually coming in from the northeast. So now everything is lit as if there's a sun to the northeast. Next up, we're going to do the model vertex. So let me show you what the class definition looks like. The model vertex is kind of like the same as the render vertex, but instead of being a gigantic struct of bytes that are addressed in different ways, it actually has human readable properties. And this is where we want to add our lighting direction. It's going to be a decimal byte 3. This is a normalized vector with just bytes as their components. And we're going to call it lighting direction. Get the C++ file. We have this huge comparison operator, and we have to add like a term here. So this is not going to look pretty. And if anyone knows a better way to do this, let me know. But it's the way it is currently. So this compares like all of the data in the struct, so we can sort it and use it in maps. And we also check if they're equal in the same way. So let's add the lighting direction here as well. Like comparing render vertices is way more efficient because you can do a mem compare, mem comp. Okay, so we're now passing it over from the model vertex. So let's say model vertex.lighting direction. Yeah, we need to use these individual components here. So we're going to pass the X, the Y, and the Z component. There you go. It compiles and it should run, but now the lighting should be gone, or it should be completely wacko because we have a 0 vector. So as you can see, the lighting is now completely gone because there's a 0 vector. It doesn't radiate anywhere. The light doesn't come from anywhere. Now we need to set up these model vertex values, because if we open up model vertex, you can see if we actually reset properties, if we actually make a normalized vector from a full-sized vector. So this is going to work. Now we have the actual correct light. We have a way of getting it into the engine or like into the render buffers. It's coming from the top. It's not blown out. It's normalized in OpenGL and it's normalized in our engine. So we need to make sure that we set lighting direction in the engine, in the model vertex, to a normalized vector from a bigger vector. This is actually the way we're going to do it.